All right, ladies and gentlemen, here is our screencast, so our video notes on comparing the Earth's 4 basic subsystems. So we're going to do a little comparison of things that happen in those systems. We're going to also talk about things that would occur between those subsystems of Earth. So your target right there, we're going to show knowledge of Earth systems. So yesterday we kind of mentioned in our daily question what the Earth systems are, those subsystems. We need to talk about how they're dynamic and interacting, so how they're ever changing, and how because they are interacting, we're going to see those changes. We're going to talk about the feedback effects that can increase or decrease those original changes as well. Okay? So make sure you write target down, make sure you have the title on your notes. Again, this is also going to be linked to Google Classroom, just the original set of notes without the actual screencasts. So if you want to go back, without the video, you can always do that, or you can just pause and go back, however you want to do it. Alright, so Earth system. So we talk about the Earth system. We're talking about the system of Earth and those systems that kind of make up Earth. So again, there are many systems that are interacting all over Earth, all of which are ever changing. Okay, they're never stagnant. It's always going to be changing. Okay, and then as I said earlier, we talked about the 4 subsystems of Earth, and those being dynamic and working, and interacting with one another. Those subsystems, again, just to go over them. So this is a nice little picture, kind of gives you the breakdown of the 4. Maybe you can guess before I go over them what those subsystems are just by looking at the pictures. So, the biosphere up in the top left-hand corner. So all life on Earth. In the top right-hand corner, you're looking at water. So hydrosphere. If you look at the bottom left-hand corner, we see a volcano erupting. That's going to happen within the geosphere. So the lithosphere, the mantle, the core, the outer core, the inner core, all those different layers make up the geosphere. When we look at the bottom right-hand corner, we're looking at a picture of the atmosphere, so weather that would be occurring with a lightning strike going on. So again, that's part of the atmosphere. So those are the 4. Okay, easy way to think of them. If you were to go back, one way that I always helps me to remember them would be geosphere, rock, hydrosphere, hydro, water, atmosphere, air. Think of the different types of molecules that we're going to find in the atmosphere, in that air. Okay, those different gases. And then when you think of biosphere, bio. If you took biology, biology is the study of life, so bio, life. Okay, so any life found on Earth, whether it be plant life, bacteria, animals, all that, plays a part in creating that biosphere. Alright, so those are your 4 subsystems of Earth. Today we're going to be talking about those interactive processes. So within the spheres, there's major processes that go on, and then between the spheres, we're going to see processes that can affect the individual state of those other spheres. Okay, so I've used sphere a lot, but again, that's what we're looking at. So the interactive processes, and then kind of major processes within each of those. All right, so first one we're going to start with is the geosphere. The geosphere, some of the main things you need to make sure you're familiar with: plate tectonics. So hopefully by now you know that the Earth is made up of these giant plates of crust of the lithosphere. It's been broken over time into these big giant slabs of Earth, basically. So when we talk about plate tectonics, we're talking about the movement of those plates. And with that, with the movement of those plates, we can see a lot of things happening. We can talk about, an ocean trench being formed, a volcano in the ocean that could be formed, volcanoes on land that would be formed, what we call folded mountains that might be made, a continental rift. Volcanism is a big part of plate tectonics. Also, seismology and the study of earthquakes, basically. So earthquakes would be another piece that would fit in the major processes of the geosphere. When we talk about some interactive processes where other spheres, other subsystems of the Earth kind of act on that geosphere. Weathering, which would, have aspects of the atmosphere as well as the hydrosphere being part of it. Erosion, so again, adding in that hydrosphere. We could also talk about parts of the atmosphere. mass movements. So what that's referring to would be, those mass movement of like something like a glacier. Okay, that's going to affect what we see in the geosphere, especially when we talk about the lithosphere on the top layer of the Earth. Soil accumulation. So we've talked a little bit in the past about how soil gets made. It means you have your solid rock that gets broken down over time through weathering, erosion, mass movements, all that kind of stuff, and that's going to create new soils. And then water distribution. Within that, we're going to see, because of the shape of the Earth, we're going to have water being distributed in different parts of it. So, that could mean different rivers going through, lakes, the ocean, and then also aspects of groundwater within that geosphere. Okay, here's a little video on plate tectonics. If you didn't know what plate tectonics is, here's a little quick rundown on how it kind of works. Okay, let me go back to that.
It happens because hot rock rises, heated by the Earth's core. Near the surface, the rock spreads in two directions and goes sideways. It begins to lose heat. Eventually, the much cooler rock sinks back down. Through this spreading process, the Earth's crust is very slowly dragged apart, and it's this that ultimately causes the continents to move. Where the plates collide, the rock on the seafloor containing carbon from the dead plankton is carried deep into the Earth. As it descends, this layer of rock is heated, so the rock melts, releasing carbon dioxide. And gas is returned back into the atmosphere during an eruption.
Okay, so real quick, he just even mentioned that gas is being put into the atmosphere, so you can see how there's an interactive process going on right there. So when we have CO2 and water vapor and other gases being released from a volcanic eruption, we're going to change the characteristics of that sphere, of the atmosphere. So that's an interactive process as well that I didn't even mention in the last slide.
The remarkable cycle is complete.
Okay, so there's plate. That was the video on plate tectonics. Now moving into the next subsystem of Earth, we're going to talk about the hydrosphere. So major processes going on there. We talked about, or we say water. So hydro, the main aspect of it being the water cycle. So the different parts of that water cycle: evaporation, condensation. We're going to find water vapor in the atmosphere. As it condenses, it's going to fall down as precipitation, whether it be sleet, snow, rain, hail, all those different types of precipitation. Then when it gets into, on Earth, we could see it being in runoff. We can find it in groundwater, lakes, accumulated in lakes, different streams in the ocean. So all those are part of the water cycle. When we talk about the latitude and altitude, and how it results in the cryosphere. Cryosphere is frozen water. So we talk about the different latitudes, towards the poles, we're going to have lower temperatures, altitude on Earth. So the higher you go, the colder it's going to get. So that creates that frozen aspect of the water cycle as well. The interactive processes here, so we can talk about weather, local weather in different parts. With the accumulation of water in certain areas, we're going to have weather patterns. So that's going to be an interactive process with the atmosphere. Horizontal and atmospheric transportation, so movement of that water to different parts of the Earth. Different latitudes. Again, the altitude there. The creation of those different seasons, possibly because of the accumulation of water during different types of the year. The topography of Earth, kind of definitely plays a part in, creating that weather in certain areas. There's a thing called orographic lifting, where because of mountains and, high mountains and the movement of that air up the mountain, carrying that water vapor, we're going to see weather being created around a mountain. And there's a video on the next slide that I want to show you that kind of illustrates that. So before you watch the video, make sure you write down this question. So orographic lifting and rain shadows. So there's no talking in the video, just pay attention to the clouds. Again, this is a nice little mountain range, and it's showing the accumulation of those clouds at the top of these mountains. Okay, and that's what we call, again, orographic lifting. Okay, so you can see because of the topography of Earth, the geosphere of Earth, because of that, we're going to see new weather patterns. So, and because of the water vapor that's found there, and that water vapor in the atmosphere, so we have three interacting spheres and processes going on within that. So, because of those mountains, because of the amount of water vapor in there, and because of the different gases in the atmosphere, we're going to see maybe different weather patterns occurring. So, pretty interesting. All right, when we talk about the atmosphere, again, we're talking about those different layers and the gases found within them, in the atmosphere of Earth. Okay. Major processes: air mass formation and movements. So we're going to get different masses of air, cold fronts, warm fronts, things like that, and then those are going to move around the Earth. Another thing that's going to happen within the atmosphere that is a process that you need to know about is the Coriolis effect and jet streams. So the creation of these jet streams, and the Coriolis effect, which I'll have a video on in just a second. Another one I want you to make sure you understand is the greenhouse effect, so the warming of Earth because of the ever-changing distribution of gases in the atmosphere. Those greenhouse gases you've probably heard of. One of the main ones being carbon dioxide. So putting more and more carbon dioxide and other greenhouse gases creates, it's a heavier gas. It creates kind of a blanket around Earth. That energy from the sun that usually would be reflected out of the atmosphere and back out into space actually gets trapped. And so we're seeing a warming of the Earth. And obviously that's going to affect other aspects of Earth as well, whether it be the biosphere or the hydrosphere, the cryosphere within the hydrosphere. So that, aspect of the atmosphere is something that would also kind of interact or be interactive. Some interactive processes, so weather, when it rains, when it snows, wind, all those different things are going to play a part in shaping the geosphere and also the hydrosphere of Earth as well as the biosphere. We could talk about, climate being a big part of an interactive process. So the climate on Earth is going to impact the biosphere. It's going to impact, the hydrosphere. Different climates found on Earth, we might have different levels of weather. The water distribution, if we're having weather occur in the atmosphere, obviously we're going to have different levels of water distribution on different parts of the Earth. And then also biome distribution. So a biome would be, an area where we find specific types of life with different climates on different parts of Earth. And so with different climate, different weather, we're going to find different animals. We're going to find different types of organisms, not just animals, just all organisms. So that biome distribution plays a huge part in one of those interactive processes with the atmosphere. Okay, it's all connected. All right, Coriolis effect, just a little information on that. So what it is, here's a quick little video on the Coriolis effect. I want you to just make sure you explain it. So this could be a question over the left. Explain how Coriolis effect works, okay, and what it has to do with the atmosphere, as well as how could it affect other parts of the Earth.
Picture a circle Here's its center, here's point A, and here's point B. Point A is twice the distance from the center of the circle than point B. Oh yeah, and it spins from its center. In 2 seconds, both points do 1 full revolution. But to go all the way around, point A has to go this far, while point B only has to go this far. And we all know if something travels a greater distance in a shorter amount of time, it must be going faster. So point A must be moving faster than point B. Okay, now swap out this flat circle for the Earth, and the same thing is true. All points closer to the center, say like someone in Greenland, will be spinning slower when compared to points spinning further away from it, say like people in Brazil, closer to the equator. So if we look at it all flattened out, we can picture something like this. Arrows at the equator travel faster than arrows at the 45-degree line, like we just observed. Now imagine you're a cloud that formed here on the equator. You'll have the same velocity as the Earth, but then a gust of wind sweeps you to the north, where the Earth isn't spinning as fast. Due to inertia, your speed remains the same. You don't get any faster, but everything around you is literally traveling slower, so you, relative to the ground, move ahead of everything else. If you're a cloud that forms at the 45-degree line, you'll also have the same speed as everything around you, but if you drift down to the equator, you'll be moving slower than the ground underneath you, so you'll fall behind. And the same things for the southern hemisphere. Moving towards the equator always results in falling behind, while moving away results in pushing ahead. Okay, now imagine a low-pressure cell. That means all the air around it will get sucked into the center, but the air coming from the equator will be traveling faster, so it will deflect to the right, while the air coming from the poles will be moving slower, so they'll fall behind and deflect to the left. What this results in is a circular air current spinning counterclockwise, and that's exactly what hurricanes are, low-pressure cells spinning because of the Coriolis effect. Moving this example down to the southern hemisphere, things are reversed. A low-pressure cell will still suck in the surrounding air, but now the air coming from above will be moving faster, again deflecting to the right, while the air coming from below is moving slower, again falling behind by moving to the left. This results in a clockwise spin, which is why storms in the southern hemisphere spin this way. And that's about it. It's a short video, and that's kind of the point. I hope you got what you came for. And the Coriolis effect doesn't really influence toilets, they're just really too small.
Okay, so that's the Coriolis effect. So you can see how it works to shape, extreme weather systems on Earth. It can also work to shape the different currents that we find on Earth in the oceans, because the Earth is spinning, and we see that water being moved. When it's moving towards the equator, it's going to be deflected in a different direction, depending on where it's coming from, whether it be the north or from the south. So that's, again, another thing that's going to shape not only, weather patterns in the atmosphere, could also help shape the different parts of the hydrosphere as well, which again could play a part with shaping the weather patterns that we see in the atmosphere. So again, just another connection being made between the different spheres of Earth. Okay. All right. The last one that we're going to cover, give me 1 second, is the biosphere. So, biosphere, all life on Earth. So when we look at the major processes, we're looking at biotic distribution. So where do we find life on Earth? Where are the highest levels of what we call biodiversity? Where, with the amount of nutrients that they need, the biodiversity levels may be different in different parts of the Earth. Another process that's going to happen within the biosphere is evolution. So the changing of those organisms over time. Okay? What leads to that is adaptation. So adaptations based on, where they're found. So organisms change due to the environment that they're found in. So again, we've talked about all the different things that can change different parts of the Earth. As those change, organisms need to change along with it in order to survive and thrive. Okay? So those are the major processes within the biosphere. Some interactive ones. Believe it or not, biosphere and life on Earth actually plays a part in creating different weather patterns. Local water vapor levels increase by more amounts of biomass. So the more organisms there are, the more mass of life that there is, the more water vapor levels will increase, and the different types of weather. So if we look at the rainforest, okay, we're going to see a lot more rain happening. Again, it's more towards the equator, but also we have more biomass releasing more water vapor. It's kind of a double whammy effect. We think of climate. Unfortunately, humans also contribute to climate. So, by what we are putting into the atmosphere, on a daily basis with those greenhouse gases. We have negatively impact, the climate. So we've impacted, how warm the Earth is getting. Plants are also a major contributor to this as well, just because they are also using respiration. But again, humans, we not only use respiration as a main process to survive, and same with all organisms on life, but then we are also adding more than our fair share. Another interactive process would be soil composition. So we talk about the different microbes that might live in soil to create new soil. We could think of earthworms and the breakdown of different parts of the soil, putting back in those nutrients. Okay, so that again goes into the parts of the geosphere, and then also weathering as part of it. So we could add in aspects of the atmosphere and the hydrosphere to create that different soil. So the biosphere plays a huge part in creating new soils as well, or creating soil. Marine sediment accumulation. So when we look at the bottom of the ocean floor, we're going to see marine organisms die and accumulate. So we create new types of rocks. So limestone being one of those main ones, where we're going to see the remains of dead organisms being incorporated into those different types of rock. And so we're going to see possibility for new geographic features at the bottom of the seafloor. So all those processes are going to be interactive. And you can probably think of a couple more even, or maybe do some research and find some more. But again, the main thing that I want you to understand in these notes is that all of these are constantly interacting. So we're looking at the different subsystems that are interacting, they're changing. It's dynamic. So the Earth is never stopping. It's continuously creating and recreating and changing, due to these different subsystems and how they interact with one another. Okay, so I do have a video here. I'm not actually going to show it in the screencast. What you would want to do is just go to the notes or go to YouTube and watch it. And I want you to use this video to help you summarize. So he's going to go back over a lot of stuff. He's also going to talk about matter and energy and how it gets kind of recycled within the Earth. So take a listen to him, and then if you're still confused, we can talk about it. But just use this to help me kind of wrap this up and summarize your notes. I hope that was helpful.